Welcome to our cosmic journey through the universe's most mysterious objects, black holes. From their formation in the death throes of massive stars to their potential role in the evolution of galaxies, black holes offer a glimpse into the most extreme environments in the cosmos. Get ready to have your mind blown by these incredible facts. We'll explore the science behind black holes, their bizarre properties, and their impact on the universe around them. Fasten your seatbelts, space cadets, because we're about to take a deep dive into the heart of a black hole. Black holes, those cosmic gluttons that devour everything in their path, don't just pop into existence out of nowhere. They have a beginning, a dramatic origin story written in the heart of collapsing stars. Imagine a star, much more massive than our sun, reaching the end of its life. The core collapses in on itself, crunching down to a point of infinite density, a singularity. The outer layers of the star are violently ejected into space in a spectacular supernova explosion, a cosmic light show that outshines entire galaxies. And there you have it, the birth of a black hole. Now, if you were to approach a black hole, the first thing you'd encounter is the event horizon. This isn't some physical boundary like a brick wall in space. It's much more subtle and far more terrifying. Think of it as the point of no return, a cosmic line in the sand. Once you cross it, there's no turning back. The gravitational pull is so intense that even light, the fastest thing in the universe, can't escape. Imagine a swimmer trying to swim upstream against a current that's getting stronger and stronger. Eventually, they'll reach a point where no matter how hard they struggle, they'll be pulled backwards. Now, at the very heart of a black hole, hidden behind the veil of the event horizon, lies the singularity. This is where things get really weird, even by black hole standards. The singularity is a point of infinite density, where all the matter that ever fell into the black hole is concentrated. Imagine taking all the matter in a star, or even a galaxy, and squeezing it down to a single point. Now, our current understanding of physics breaks down at the singularity. We need a new theory of gravity, perhaps a quantum theory of gravity, to fully describe what's going on there. It's a cosmic mystery that continues to baffle physicists and fuel our imaginations. Chapter 4. Hawking radiation black holes aren't entirely black. For a long time, scientists thought that nothing, not even light, could escape the clutches of a black hole. But then, along came Stephen Hawking, a physicist who revolutionized our understanding of these cosmic behemoths. Hawking showed that black holes aren't entirely black after all. They actually emit a faint radiation, now known as Hawking radiation. This radiation is the result of quantum effects near the event horizon, where pairs of virtual particles are constantly popping in and out of existence. Think of it like this. Imagine the event horizon as a boiling pot of water. Occasionally a bubble of steam escapes from the surface. That's kind of like Hawking radiation. Chapter 5. Supermassive black holes, the heart of darkness. Now, we've been talking about stellar mass black holes, those that form from the collapse of massive stars. But there's another category of black holes that are truly mind-boggling in their scale. Supermassive black holes. These cosmic titans can have masses millions, even billions of times greater than our sun. And here's the kicker. We find these supermassive black holes lurking at the centers of most galaxies, including our own Milky Way. Imagine a giant whirlpool, a gravitational sinkhole, holding sway over the entire galaxy. How they form and evolve is still a mystery, but we know they play a crucial role in the evolution of galaxies, shaping the cosmic landscape as we know it. Chapter 6. When black holes collide, a cosmic symphony. Now, imagine two black holes, locked in a gravitational dance, spiraling closer and closer together. As they approach, they warp and distort the fabric of space-time, sending out ripples, like waves on a pond. These ripples are gravitational waves, and they travel across the universe at the speed of light. When the black holes finally collide, it's one of the most energetic events in the universe. The energy released is equivalent to converting the mass of several suns into pure energy, according to Einstein's famous equation E equals Mach squared. These collisions send shock waves through space-time, and they create a black hole even more massive than the original two. Now let's talk about what would happen if you were to fall into a black hole. Spoiler alert. It's not going to be pretty. As you approach the black hole, you'd experience something called spaghettification. Imagine being stretched like a piece of spaghetti, your feet feeling a much stronger gravitational pull than your head. This tidal force, the difference in gravity's pull across your body, would become more and more extreme as you get closer to the singularity. You'd be stretched out like a noodle, thinner and thinner, until eventually, you'd be ripped apart at the atomic level. So, while black holes are awe-inspiring objects, it's probably best to admire them from a safe distance. Chapter 8. Time Warps and Black Holes. Black holes are not only cosmic vacuum cleaners, but they're also cosmic time machines. Einstein's theory of general relativity tells us that gravity warps time. The stronger the gravity, the slower time runs. Now, since black holes have the strongest gravitational pull in the universe, they warp time more than anything else. If you were to hover just outside the event horizon of a black hole, time would slow down for you relative to someone far away. Imagine you could watch a clock fall into a black hole. As it gets closer to the event horizon, you'd see the clock ticking slower and slower until it appears to stop altogether. That's the mind-bending nature of black holes. Chapter 9. Black Holes on the Silver Screen. Black holes have captured the imagination of filmmakers for decades, serving as both awe-inspiring backdrops and terrifying antagonists in science fiction. One of the most realistic depictions of a black hole is in the movie Interstellar. Remember that visually stunning black hole, Gargantua? The filmmakers worked with physicists to create the most accurate simulation of a black hole ever seen on film. They even got a scientific paper out of it. Of course, not all black hole depictions in movies are scientifically accurate, but that's okay. Science fiction often takes creative liberties, using black holes as metaphors for the unknown, the unknowable, and the potentially terrifying aspects of the universe. Chapter 10. Unraveling the Mysteries, the Future of Black Hole Research. Black holes remain one of the most tantalizing mysteries in the universe. But with new telescopes and observatories coming online, we're entering a golden age of black hole research. We're already detecting gravitational waves from black hole mergers, giving us a new window into these cataclysmic events. And with the Event Horizon Telescope, we're getting our first ever images of the shadows cast by black holes. These observations are helping us test Einstein's theory of general relativity in its most extreme limits, and learn more about the role of black holes in the evolution of the universe. Outro, keep exploring the cosmos. Thanks for joining us on this journey through the fascinating world of black holes. From their formation in the death throes of massive stars to their mind-bending effects on space and time, black holes continue to captivate our imaginations and push the boundaries of our understanding. Remember, the universe is a vast and mysterious place, full of wonders waiting to be discovered. Don't forget to like, subscribe, and hit the bell icon for more cosmic content. Until next time, keep looking up.